Hello and welcome everyone. Thank you for joining us today for our webinar titled Winning Solutions for Analytics, Reducing Lower Body Injuries in the NFL. My name is Patrick Moran and I'm on the marketing team here at H2O.ai. I'd love to start off by introducing our speaker. John is a customer data scientist. John Miller is a customer data scientist at H2O.ai. He works with H2O customers, helping them improve by using their data and driverless AI. His current project involves building a machine learning pipeline that classifies information from document images. His technical expertise includes predictive modeling, machine learning, and statistics. Before focusing on data science, John worked as an operations consultant where he used analytical methods to help companies improve processes and business operations. John graduated from MIT's Leaders for Global Operations program with master's degrees in both business and engineering. He also holds a BS from the United States Military Academy at West Point. Before I hand it over to John, I'd like to go over the following housekeeping items. Please feel free to send us your questions throughout the session via the questions tab. We'll be happy to answer them towards the end of the webinar. And this webinar is being recorded, so a copy of the webinar recording and slide deck will be made available once the presentation is over. Now, without further ado, I'd like to hand it over to John.
Thanks, Patrick. How's my sound coming across?
You sound great.
Okay, great. Well then, hey, thanks and welcome to everyone. I want to talk with you today about analytics and how to create a winning solution for analytics, not only on Kaggle, but in your work life too. It's interesting how this came about, and so if you're familiar with Kaggle, they've historically been a place with, where they host online machine learning challenges, and so you go, into a situation, you build a machine learning model, and it gets scored. They've started recently. They started, I think, with the first major competition about a year and a half ago, and then another one recently, which they call analytics challenges. And so we'll talk about how those are a little bit different. My, sort of claim to fame is that I participated in both of those analytics challenges and was a finalist in both, and got to present my findings to the NFL, and it was pretty cool. And they actually used one of my findings and recommendations as support for one of the rules changes last year. So we'll see what they do with the competition this year. We just presented, I guess, about 2 weeks ago during Super Bowl week for this latest challenge. So we'll talk about those and how those work, and give you some tips, and hopefully give you an opportunity to ask questions as well. Okay, and so here's the agenda just one more time. Okay, we're going to talk about, setting the priorities for analysis. Like, how do you start with an analytics challenge before you jump into machine learning and so on? When you do get to the machine learning piece, what do you do with it then? How do you apply it in the right context? We'll definitely talk about, communicating with a business audience and how you should, think about ways to talk to different audiences, and then just some very practical tips on Jupyter notebooks and how to improve the readability and keep your people engaged a little bit. All right, so a little more on analytics. This term, there are terms out there that people use and use them in different ways. And so in today's case, we can get on a common page for the term analytics. And I'll start with just by talking about the difference between, a Kaggle machine learning challenge and a Kaggle analytics challenge. And so in a machine learning challenge, as I mentioned just a little while ago, your goal is to build the best model. You get a score, there's an evaluation metric, and you build a machine learning model, and your goal is to have the highest scoring model. An analytics challenge is much more open-ended. You pretty much are asked to provide insight, first of all, and along with some recommendations that the host can use to improve their operation. In this case, for the NFL competitions, they were both related to the health and safety of players. And so the first one was along the lines of reducing the concussions that a player might experience. And the second, this last year, was to reduce lower body injuries. So the goals are stated up front, hey, we want to reduce lower body injuries. Here's some data, here's some things to think about. Tell us what you can find, okay? So that's the first thing. Another difference is that in a machine learning challenge, you have train and test data. So train and test data are provided, they're split up, and if you've been part of the competitions before, you know that, yeah, there's usually a training set, then in the test set, there's public test data and private test data, and those are all predetermined. In an analytics challenge, you do get data, but there's no split. No one is there to, basically say, hey, here's train and test. It's kind of up to you how you want to do that. You may not even use supervised machine learning. You may use unsupervised and divide the data up a little differently that way. There are different options that you can see in there, and it's all different depending on the challenge. I'll talk about some specifics for these two analytics challenges when we get to that, and how I use machine learning there. So another difference is that, in the machine learning challenge, the machine learning is the thing. I mean, that's what you're there to do. You're there to build the most, the highest performing model. Whereas in analytics, it's part of the thing. In last year's competition, which was to reduce concussions, a lot of the finalist submissions really hardly used machine learning. I think in my case, I used it in an unsupervised way, but it didn't provide a whole lot of insight, and that was just based on the nature of the data. Sometimes you have data that machine learning is hard to really use, especially, in the time provided and with data limits and that sort of thing. This past year, machine learning proved much more useful, and so I'll show you an example of how that was as well. And then finally, how's the winner determined? And so this is more specific, I guess, to Kaggle, but the winner's determined by the best score on the private leaderboard. There's no question. It's completely objective. It's determined by the evaluation metric and any other constraints. In an analytics challenge, it's quite different. The winner is determined by people. So there's a group of people that are going to review the reports and the submissions, and then they're going to declare the winners or finalists according to a set of criteria. And sometimes the criteria is spelled out. This year, it was in the competition. It was fairly well spelled out. The year prior, there weren't any specific criteria. It was just more like, hey, how useful are your recommendations and how useful is your insight? Now, if you think about it, this is not too unlike the real world, right? I mean, when you're there in front of a business owner or a decision maker talking about how you did your analysis and what insights you have, that decision is not fully transparent, and hopefully there is discussion and there's back and forth that helps those things come out, and your audience can present some criteria, but it's not always the case. A lot of it comes down to some more intangible factors, and that's why I want to talk about communication a little bit, because the way you communicate and apply those soft skills are really going to help your good analysis and your good machine learning models shine through. All right, so those are the differences, in Kaggle, and like I was saying, it's kind of the same thing in the real world. There's this broader analytics picture, so we'll use that, sort of as the terminology there. And then within this analytics problem, there are different tools and techniques you can use, machine learning being one of those. Okay, so a good first part, when we're talking about how to set up an analytics problem, the first essential part, I think, is to frame the problem in the right way. So, just like with a machine learning competition, a lot of the grandmasters will say that, do not just jump in and start running models and, spinning up XGBoost and running through some cycles, some iterations. Stop and think about the problem, think about what you're trying to do, think about what the data shows you. That is all great advice in any sort of problem you're trying to solve. And these analytics challenges are no exception. And so, the first thing you want to do is just kind of think about your overall problem-solving methodology. And so the examples that you see on the slide here are tools that I used with the information I used from last year's analytics challenge. And so again, the idea was to reduce concussions, and they were specific. They were really good about, as a host, as a business, providing a specific, business problem to solve. And the way they did that was by saying, hey, we want rule changes to reduce concussions associated with punts, with punt plays. And so when you look at that logic tree, the logic tree is a way to go through several options and sort of prioritize your efforts. So that key question was fairly easy to get to, because the NFL was really good about outlining that they wanted rule changes. They could have said, hey, what changes can we make? And then you have not only rule changes, but you have technology, and you have behavior, and you have all of these different things. And so this was a good case. But back to the left-hand side, with problem-solving methodology, this is really just what you see here is really just an adaptation of the scientific method. I think it's what we generally do by nature as data scientists, as engineers, coming from that background. You're always starting out with the problem, understanding that, moving on through, doing some analysis, get your correlations, causes if you can, and then the important part for the follow through here is really getting to those proposed changes. So hey, here's some ideas, and then getting from that to execution. Now, a lot of times in our field and with the Kaggle challenges, the execution is on somebody else. And so our job is really just to set it up so that once a decision is made, that execution can be done and the right results, occur. So in terms of some of the tools you see below each of those steps in the methodology, some of these methods, some of these tools, that you can use. And the logic tree is one that I show to the right. One other that you see there is decision matrix, and you may be familiar with a decision matrix. It's really just a table of pros and cons, and you can get fancy with it in terms of weighting different criteria and that sort of thing. But really, it's another tool in the toolbox to kind of say, okay, we've done this analysis, we have some different ideas. Here's how we can decide through those. So now back with the logic tree, this is something that I found very helpful. I think that it helps people understand how you're approaching a problem from the very beginning, so before you get into machine learning and all. And the logic tree, again, it starts with the key question, and what it's designed to do, you could probably tell by looking, is just to outline the opportunity space. So if we want to make a rule change that reduces concussions, what are our options? And so at the first level, you can just think through this very methodically. And you can say, okay, well, we could make each punt less dangerous. We could have fewer punts, or we can have punts basically be the same, but reduce the severity of the concussions. And that would be the continued observance of the current protocol's rules. Now, looking back on this, of course, I made this a year ago. If I had it to do all over again, I would probably expand the tree just a little bit. And my first level would be, it would be around less danger on each punt. Okay, and then the other one would be, so the first two, each punt less dangerous, that's really about reducing concussions, reducing the number of concussions. But then I would have a second branch that is about reducing the severity of each concussion. So you can go two ways with that. But to make the point, you're just basically breaking this down further and further until you get down to things you can take action on. And in this logic tree, you see I got down to 5 opportunities, and I said, okay, we can have fewer live returns, we can have less harmful contacts, safer strategies, etc. And out of those 5, I chose the top 2, and that was based on some preliminary analysis of which ones would have the most impact, where I thought the data was most useful, and then maybe a little bit of a look ahead to kind of what's going to actually be able to be reasonable for the NFL to enact. Okay, and that's something you can do in any situation. Think about sort of the end game. Think about what it is you're trying to do, and then let those things and your data and your timeline and all of these other things, help prioritize your efforts. because there's never, it's almost never time to go after everything you can go after. So, here I had 5 opportunities. I chose 2 and went after those. Okay, so logic tree, very helpful, and there are a lot of examples you can find out there in reference material to learn to use those more effectively. Okay, so once the problem has been framed, there's something to, and this may actually kind of come before or with it, in terms of understanding the problem. Like, there's really a lot of attention that you should pay in this stage. Just like with the machine learning problem, you really are trying to get to, hey, what are we trying to predict? What are we trying to classify? What are we trying to group? And understand what that is. It's the same thing here. And in a Kaggle Analytics challenge, you get about a page of context in terms of what the host wants, and what the NFL was looking for in this case, and what they're trying to do. With this last competition, they left it a little more open-ended, and so you had to read it carefully. And I don't have the example here, but when you look at the page, they talk a lot about, first of all, reducing lower body injuries. So that's like knees and lower limb injuries, really. So knees, ankles, feet, that sort of thing. There's been a lot of talk about synthetic versus natural turf. And so that was another main aspect of this, where you wanted to look at injuries on synthetic versus natural and see if there are any differences. Then they brought in an angle of player movement, and so they wanted to know, hey, do players move differently on one versus the other? And then they talk about the environment. And so you can see, as you start reading through these things, it starts to get, the picture starts to become a little less clear. I mean, you get more information on what they want, but, just like when you're getting customer requirements, the more they give you, the more sometimes things, become less clear. So you really had to think through like what the NFL is trying to do. And that's where gathering domain knowledge comes in. So gathering domain knowledge is really important. In a machine learning environment, I think in the real world it's important also, maybe less so. In Kaggle, certainly, in Kaggle with the machine learning competition, there are, many, many examples of grandmasters and others, really just anybody, winning a competition without much domain knowledge. And that's because they have a lot of functional expertise in machine learning. They have techniques and ways to squeeze every little bit of information out of the data that they have, and those things are useful in any domain. In analytics and even in regular company work, domain knowledge is really important. And so you want to start out, researching. There's a lot of different research you can do, but you want to understand like what's important. You can also team. So I put a thing in there about team. If you don't have the domain knowledge, of course, team up with somebody who does. But here it was important because the NFL is asking for all these things. Well, it's interesting to know that somebody else is already looking at, for the NFL, someone is already looking at the interaction of turf and cleats. So turf-cleat interaction is important, but you might not want it to be the focus of your analysis here, because this is really about turf and movement and environment. So things like that, things try to get in. Just understanding what the past has been, like how big is this problem? So you go back and look at injury data that may not have been provided. In this last case, we got a sample of data, and it was a good sample of data for knees and ankle injuries that we could use, but it didn't give a sense of how big the problem was. And so, one of the first things you want to understand is, well, how big is this problem? It turns out that it's fairly big. The NFL loses a lot of players, a lot of time, and so there are ways to quantify that. But anyway, domain knowledge is very important, and I'll talk about that more as we talk about visuals. We'll get into some actual pictures and kind of out of these bullets. All right, and then finally, the other thing is always keep the end state in mind, just as when you're solving any problem. You're trying to get to a feasible recommendation, so don't lose sight of that. All right, moving on. Okay, we'll get into some more concrete things. As I talk through it, some of this sounds a little abstract, so I hope we have some good questions that'll tease this out. Okay. All right, my screen is showing a little bit differently here, but we'll talk about machine learning. There we go. Okay. So machine learning is an important piece of your analysis. And the reason is because, hey, that's what we bring to the table. As machine learning engineers, data scientists, and so on, we have that skill set that companies may have not had access to in the past. And so before, whereas someone might provide, more traditional statistic analysis or business analysis, that's all great. What we offer is, some additional insight, hopefully, that comes from machine learning. So it's a big piece. The thing you have to remember, though, is that it's going to work best if you can use brain-friendly models. Okay, so if that's the first thing. So if you look at, the bar chart down in the bottom, that's a fairly brain-friendly model. That's where I was looking at the lower body injuries and looking at the factors and the relative importance and trying to, let people know, hey, here's what's most important. And notice you can read through those different factors, fewer days between games, precipitation, high temperatures, and get a pretty good idea of what those mean. Contrasted with what you might get out of a, just a default plot, which is going to have, factor names that say maybe like, average max day games, or, some of the shorthand we use. Also, if you want to build a good machine learning model, we know that interactions are very helpful. So you can get some great interactions and such too. But if someone's not initiated to, to machine learning, and they see this factor that is, a combination of two categorical factors with some weight of evidence, thrown in there, some encoding, that's going to confuse people. So you have to either be prepared to explain it, or you have to be able to translate it into something that's more, as I call it, brain-friendly, just more user-friendly. And again, that's going to depend on your audience. Certainly, you're going to have a very different conversation with your teammates and your data science group than you are with the business, someone who's trying to consume this information. And so you want to make sure you tailor that. And so then the other thing with machine learning, and it's not easy, is to think about how to explain what a model does. So the chart on the right, the plot there, is actually outside of the NFL. That is some work that I did in a court case where we were trying to show which vendors may be acting differently according to the data. And so this is a Teasney plot, a two-dimensional Teasney plot, which you may know is sort of just think of it like it's reducing dimensionality, but in a very simple, naive way, it's clustering. And so we're putting all of these vendors down on the page, and we're condensing all of their data and all of the factors, the features, into just two main components and seeing how they fall out. Well, Teasney works in a very specific way, and trying to explain that to a layperson is really hard. And so you have to try to think about how to do that. One way that we did is, we said, hey, imagine that this plot you're looking at, and we showed a before. So the before is just a big mush of plots, of dots, and everyone's in a room. And you say each of these vendors is represented by their manager or owner, and they're in a room with each other. And their job, or what their goal is to start just sort of grouping together with other vendors that are like them. So start associating with the vendors that are like you, and look at all these different factors. And as you do, move closer to vendors that are like you, and move further away from vendors that aren't like you. And so there's some explanation that we set up, and there's some nice animated visuals you can use to show that kind of explain, like, okay, at the end of the day, this is how we get to a Teasney plot, and this is what it means, and this is what it means to be part of group 2 with all of these known suspects versus, more in the middle, away from the suspects. So again, it's not easy to explain, and then especially when you get into deep learning and neural networks and those things, it's hard, but it's worth the time, and you want to just try to make it simple and visual as possible. Even just a static chart like this and my verbal explanation is not enough. It's something that you just, you really want to take time to do. So the whole point of that is that, hey, machine learning is a really important piece. You want to make sure it has the impact that it needs to have. And so think about those things when you do. And so, back on the left, that is actually the importance plot that I showed to the NFL. And it's not the full plot here because I also have, a headline in there that basically, tells folks what the takeaway is, which is, hey, synthetic turf is important, but it's not the only important thing. It's not the most important thing. So, that was a little bit different than what some other folks found. It was different than how I portrayed the message initially, but as I sifted through and talked with people and everything, they're like, hey, this is the key message. Playing on synthetic turf is important, but it's not the most important. Rest between games and the environment and the acceleration forces on a player's body are going to be more important there. So, you want to call that out. You want to put it in a very simple way, a nice clear graph, that sort of thing. Okay. So another part of machine learning, and here's just a little bit for driverless AI. So when I worked on this last NFL challenge, I used an XGBoost model, and that's basically because gradient boosting is just sort of my go-to for these sorts of things. So I tried XGB. I might have tried light GBM at first. I stuck with those two. I think I tried to throw some generalized linear modeling in there. It didn't work out so well. So anyway, I did some different things, and I created an initial model that clocked in with an AUC of around 0.65, I think. And then I spent some time tuning and this and that, and sifted through factors, and did all the things that we do to tune a model. And I got up to about 0.75. And then somewhere along the line, I said, well, you know what? I have this access to driverless AI. Let me plug that in and see. And so I put my original features all in and so on. And if you look at the description there, it looks like it ran for a little over an hour, and it came out with an AUC of 0.77. Now, what's interesting is that there were a lot of features engineered, and there were a lot of different things it did. The data was a small set here. It was a really small set of data, especially when you aggregated it to the player level. So there wasn't a lot of extra to extract. But even so, driverless, certainly improved my initial untuned model by 0.1 on the AUC, and was a little bit better than my final model with an hour of effort versus, probably about the day that I spent. I spent at least a day, excuse me, working on this model, and would have spent more if accuracy were really important. I would have spent more time on it, whereas a driverless would have been great leverage there. And the only reason that I didn't spend more time is because again, I was looking at machine learning in the right context here, and my goal was not to build a predictive model that could predict whether a player would be injured or not, because that's not what the NFL was asking for. The NFL is asking for factors and factor importance and trying to understand what's relevant with players getting injured. So, I felt like once I got to 0.75 and above, given the data that we have, heavily anonymized, etc., that was going to be directionally correct in identifying relevant factors. So, and excuse me for one second, please. Okay, thanks. So now let's talk about communicating a little bit. And so the title of this slide is actually communication. And there are some things that you just have to keep in mind as you're going through, okay? And one of them is around what's important to communicate. And so here's an example that this is actually something I wrote, and this was for the last year's challenge, where when I talk about the problem, I start out with a lot of what I did. So I say, hey, here's what my first activity was, this, and then I did that, and then I looked at this. And that's okay for setting up some things, but really when you're sitting in front of a decision maker, that decision maker wants to know why he or she is there and what you are telling them. And they want to know what they need to do. Do they need to make a decision? Do they need to give you support? Do they need to, get resources, etc.? So you want to have more of the why and the so what than just a lot of what you did. And so if I was going to do this over again, I would probably flip it around, and I would say, hey, punt plays are 1.2 to 1.4 times more dangerous than pass and run plays, and here's what we might be able to do about it. And then, okay, now you have that seed planted, you have sort of that frame built, then you can talk about what you did. Well, how'd you get there? Well, okay, my first activity, da-da-da-da-da. So, lesson one, really talk about the why and the so what, and then dive down into how you got there and all the different steps. And again, this varies at your level of audience. When you're doing a model review, or you're talking through some findings with your data science team, everyone kind of knows what the why is about, and you've been working on the same project maybe. And so if that's the case, it's the what and the how that's interesting to that group. But as soon as you start, moving things forward, consider that you want to start focusing more on the why and less on the what. The what can always be in an appendix. It's certainly important at times. Just realize the difference there. Okay, so another lesson that's good to keep in mind is that your charts should really relate to the audience that you have. So here are a couple examples again for American football for the season. And I didn't mention it, but we were given data for 2 complete seasons. So we had injury data for 250 players over 2 seasons. And remember, we're asked to, talk about the impact of synthetic turf and those other factors to see what their impact is on player injuries. Well, if you're going through and doing just some, sort of regular EDA, exploratory data analysis, then it's very easy to kind of get right into, making bar charts and dividing things into, okay, how many players missed how many days and that sort of thing. And that's good because it gives you a sense of the data, but to somebody who's actually managing a team or playing the sport, it doesn't really give them a sense of how that works. And so if you look at the chart on the right, that's something that a coach or a manager or even a player can latch onto because it puts things in terms of players. Okay, so as you go across, you're looking at the percent of players not injured. We have 2 groups. One that played mostly on natural turf in a blue line, and one that played mostly on synthetic turf in the orange line. And we go across the number of games. And so, and we see, once you get to 6 games, the blue group who played mostly on natural turf only had 92% of that group still there. 92% were not injured, as opposed to the orange group on synthetic turf already at 83%. So there someone can see, it's like, oh, okay, hey, when I get to 6 games, that's a bit of a difference, losing, up to 83% of my people as opposed to up to 92%. So that sort of thing helps people identify with what the chart's trying to tell them. Another small note here is if you look at the scale, that scale on the x-axis is by 4s, so 0 to 32, as opposed to usually we see 5, 10, 15, 20. Well, that's because in this case there are 16 games per season. So, players and everyone in the industry will typically think of a season, a regular season of 16 games. And then 8 games is halfway through the season and so on. And so that's just a natural way to think about how things progress. All right, so something to keep in mind, a lot of times companies will work in terms of quarters and months and weeks. And so using, those sort of metrics that line up with the way people think about things is always very helpful. Okay, more on communication. So here is a lesson I learned on complexity. So this is a Sankey diagram, a flow diagram that I used to talk about concussions last year. And I have to tell you, I was very proud of this Sankey diagram, and I still am. I love it. Like it's really one of the first times I've used one in real life. And I used the HV plot library. No, actually, I used HoloViews. I used HoloViews straight out with this, and you're able to match the colors for the positions and do different things. And what it shows basically is it shows for concussions, every time there was a concussion, who was the injured player? What position did they play? What was their activity? And then from the other side, who was the other person? Who was the partner in the concussion? Because there's usually somebody doing something that initiates a concussion. Usually another player, sometimes it's the earth, but they have an activity as well. So you can imagine this is like 2 players running in towards the middle of the chart, and this will tell you everything that was happening for all of the concussions over 2 seasons. So I really liked it. The problem was, at one point, I only had 5 minutes to talk about my entire recommendation, my whole set of recommendations. So with 5 minutes to cover completely, there wasn't enough time to set this slide up. And I tried on 2 different occasions with 2 different, somewhat different audiences. And the first time, they said, "Hey, we don't understand what you're showing us." And granted, this was a largely non-technical audience, but also a very literate audience, business literate, college educated, seen many charts and things like that. But the long and short of it was that they didn't understand it. And so the second time I tried to go through and set it up, and it took about a minute or a minute 30 to set up, which in most cases, you have time, right? You can talk people through this. You can show a little bit at a time. You can sort of help, highlight from left to right. But if you don't have that time, something like this is hard to pull off. And so I finally caved into my audience demands and said, okay, you're right, we'll put this in an appendix. And I ended up using the inset chart to the right, just 2 simple bar charts. And the thing is that, when you're really just talking about the so what, it's really the 2 callouts. You have 7 players on that offensive line, and they accounted for 20 concussions. 6 of them were due to blindside blocks. Like, that's what matters. So a bar chart worked great for that. So I used the bar charts. People understood it right away, took no setup, and I could move on. So interesting lesson learned there. It's always a balance in how you sort of balance the complexity of something with your need for communication. All right. So finally, we can get into just some specific things about notebooks. So if you use a Jupyter notebook to make a report, it's a great tool. You can do some development in it. I think a lot of people will use other environments for development, but for reporting, it's great. Yet there are some limits. So you can, and with the markdown, when you have a markdown cell, those of you who've used it, that you can put the hashtags and you can have headings 1, 2, 3, 4 and different levels, and it's great. It's it's a quick way to get things very readable. When you start getting into a really long report, or if you start using it over and over, there's a lot more you can do with it. And so one of the things that I found you could do is you can use some HTML styling. And it's not that hard. You can find examples in different places. You can go onto Kaggle and look at my notebook there for the NFL challenge. You might see some other examples to get code like you see here on the left. And you can set up your own custom headers. So instead of, hashtag levels 1, 2, and 3, you can set them up as different divisions in HTML. And the difference is something you'll see on the right. You can just have nice custom section dividers and colored headers and all of that sort of thing. And the idea is not just to make it pretty. The idea really is to allow your reader to keep track of where they are as they go through a report. So in this case, my report was about 10 pages long. It has a table of contents, but it's easy to get lost down in that as you're going through. So something like just as simple as a big blue section header reminds people that, oh, okay, hey, now we're transitioning to this next section. Numbers are another good way, just 1, 2, 3, 4, 5. And it just helps people keep this whole thing in mind and not get, sort of swallowed up by the details. And in this case, that was helpful because, the panel was sifting through, I think it was like 150 or more different reports after the first screen. So they got the whole mess in. They quickly screened out, ones that did not meet the reporting criteria. And then out of the next 150, they had to go through and, sort of divide those up into review again or don't review or not sure. And so something like this just really helps them work through quickly and get a sense of what's going on, and that way. Kind of like they say with resumes, you do things to make your resume land in the right pile before someone takes a closer read. It's kind of the same thing here. Get a reader's attention, give them a sense of what's going on, and then they can dive in. Okay. So just a little tip there that might be helpful. And then the second one, the last one, and then we'll wrap up, is just about hiding code. So this comes down to personal preference, I suppose, but based on what I've heard most people say and based on my own experience is that when you send a notebook to somebody or talk through a notebook with someone, it's really just a good idea to hide your code. And that's, I know we don't usually like to do that because, especially when we're in our, in our teams, it's like the code is the thing, right? We all look at the code and, oh, okay, there's the method you use and there's the variables and okay, I see how this plays in. And, and we can even provide opinion like, why didn't you vectorize that? You have this apply or this lambda x or whatever, and okay, you could change that. But when you're heading outside of the group or you're trying to talk to a business audience, the code can be very distracting, especially if somebody doesn't code, and most people other than data scientists, programmers, etc., don't. So hide it. That's a long way of saying just hide it. There are extensions in Jupyter that I think allow this now. The Kaggle Online Jupyter environment allows you to press a button and hide code. If you don't have any of those things, no problem. It's easy to do. You just use the code here, and when you click on that box, it hides all your code, keeps the box visible, and you can just go on. And so people tend to like that pretty well. And then when people are interested in the code, then you just click on it, or they can click on it themselves if they're reading at their desk, and they can dive in. So small thing like that I think can make a difference. All right then, coming up on time, and to wrap up, what we talked about here is just try to consider the problem and the framework up front, just as you do with any problem. With analytics, think about what the challenge is, think about your end state, set that roadmap and prioritize before you jump in and kind of run around. And it can be iterative. I didn't mention that earlier, but it's okay to be iterative. As you get into the data and see what you have and don't have, you may have to go back and bring other things up, reprioritize, put some other things off to the side, and so on. Okay. Second, use the machine learning in context. Right? Use it the right way, whether it's unsupervised or supervised, deep learning or not. Try to use the brain-friendly models that people can relate to, try to explain it, and use it to support your findings or to create new insight that you wouldn't have gotten otherwise. And then finally, tailoring communication, that's a big thing, I believe. Just your audience is going to be different. And so even through the life cycle of a project, it changes. And it's very tempting to just use the same slides over and over, or the same report, but you really should change it as needed. So thank you very much for your attention. Subject to questions, that is it.
Great. Thank you so much, John. We have some great questions in the chat window, but please feel free to continue to type your questions in. We'll answer as many as we can with time permitting. So the first question I'm seeing here is asking, what are some ways to get domain knowledge on a problem when starting in a new area?
Oh, ways to get domain knowledge. Yeah, good question. So let's see. There's a couple things you can do. I mean, first of all, search engines are our friend. So you can get in and look for some things. I've found that academic papers can be useful. So for instance, let's take the example here with the NFL. I don't know a whole lot about lower body injuries. I don't know a whole lot about, or at least I didn't know a whole lot about synthetic versus natural turf. I know a little bit about football and the rules, but that really wasn't all that important for this challenge. So there are a couple things I did. One thing is I just started Googling everything, and mainly I went to and I also at the same time went to the NFL website. So, I went to their operations website. I looked at everything they'd done on health and safety. I Googled, NFL, lower body injury, synthetic turf, and really just first got an idea. Doing that, you can uncover a lot about what's going on with the organization. And so you start to learn, hey, where are they focused? What's in their head? What's important? What were, executives saying in press releases, and what did the commissioner say on TV? So there's all those things. Then you can get into, academic papers. And it turns out there are a lot of good papers written about synthetic turf and knee injuries. And so you go outside of your domain as well. You don't just look at professional NFL football, look at soccer, right? There's a lot of work done in soccer in this area, other sports. So there's the search. The other part is, talk to people, and so especially in a company environment, I found this is like the most helpful thing. Go out of your department. So if you say you report up through IT, then go find someone in the business you can talk to and learn about what's going on, like what's important to them, what are they worried about, etc. If you're lucky enough to be a data scientist who's paired up with a business and supporting a business unit, then yeah, attend those meetings, read the material that they give, just try to have that broader context. I think those are two big things, and then the third would just be team up with people. And so, you don't have to be an expert in everything. If your expertise is in machine learning, then you can partner up with somebody with domain expertise and combine your knowledge. And that's something that I see on Kaggle a lot too. You may have seen that where even, for machine learning competitions, you'll get someone deep in domain and someone really good at machine learning, and they'll kill it. So.
Great, thanks, John. Another question here is saying, thank you for the talk. It is very helpful. We are looking to start a competition soon. So what would you suggest? Should we go for a playground competition or an analytics competition?
That's a good question, and I don't know that I can answer it based on what I know, but I guess how I would think about it is that if you think machine learning, well, it's going to depend on how well you formulated the problem. If your problem is loosely formulated, in other words, you know that you want to reduce injuries, or you want to find out which dogs are most likely to be placed in a good home, these sorts of things. Those are really good for analytics competitions, because then you can get a lot of good thinking on, hey, how to frame this problem, what are the possibilities, what data is out there that you may not have thought about, because it's, in an analytics challenge, it's usually very helpful to go out and get a lot of external data and bring that in. Anything you need to really start to help focus the problem. If you think your problem is already well focused, and to the point where you have people working on machine learning models and you think you're in the right ballpark with that, then a playground competition would probably be appropriate, because it's going to get right to the machine learning, and you'll get much more focus on the machine learning part of a solution. So that's how I would consider. The only thing is that with either one of those, Kaggle is sometimes Kagglers have a limited attention span, and so both with playground and analytics, it's hard to find time for those if you're interested, say, in medals and all that. But prize money helps, I guess, and also just giving somebody like a good problem to deal with. I think that's what engages Kagglers too. So that's really all I can offer there. But yeah, that'd be exciting to see. I'd like to hear more.
Awesome. Next question, is there anything you see often that data scientists could do better when writing reports?
When writing reports, yes. So, one thing it's in our nature, at least it's in mine, to just sequentially take people through my thought process. So when I write a report, and I do this all the time on Kaggle kernels or notebooks, I'll have a notebook and I'll say, okay, first let's look at the data. And so I'll show some data. Next, let's do this, and then let's analyze this. And oh, hey, see how we got this? And I'll sort of walk through my thought process from start to finish. And at the very end, I'll say, okay, and here's our conclusion. Don't you agree? And that's how I work through the problem, and that's how we think through things. But really, you should flip it. So when you're taking that report, and people do this all the time, when you're talking to someone about it, just flip it. Like, give them the bottom line up front, right? And just say, hey, here is the conclusion. Here's what I want you to think about, because here's my opinion. And then go into, here's how I got there. And then you can go through all the steps. So yeah, number one recommendation would just be flip it, give the so what and the what to think up front, and then show people how you got there, and they will decide for themselves.
Great. I think we have a couple more minutes for maybe one or two more questions here. How how did you divide players between turf and synthetic for your survival curves? Because it seems that most players play both. Did you have to exclude any, or did you have to exclude many players?
So yes, to be clear, the way I divided them up is between players who played most of their games on natural turf and most of their games on synthetic. So I used 50% as the dividing line, and I think that was pretty close to the mean. Like it divided the players into basically two, equally sized, equalish sized groups. And so it was just, yeah, this group played mostly on natural, and this group played mostly on synthetic. And certainly there's some players there in the border, but that's how I did that.
Okie dokie. Next question. Okay, so I'm sure this is referring to the screenshot of Driverless AI here in the background. It's asking, how do you show your model impact to your audience even when your model performance was not perfect? And it's referring to the AUC of 0.777.
Yes. So yeah, the screenshot is not from my model, but it's very similar. You probably saw on the blurb, I think 777 was what the driverless model got that I ran. And so yeah, just I was upfront about it, basically saying, hey, you do not want to use this model to predict whether or not a player is going to get injured. Like, it's not accurate enough to do that yet. Maybe it will be in the future, but with the data we have, I just said, but the purpose of the model is to determine which factors are relevant. And then I talked a little bit with the audience, maybe in the report I did, but, I talked with the audience a little bit about just what that means. 0.5 is absolutely random. 1.0 is perfect. We're kind of right in the middle. So, hey, we don't know if it's going to rain today. I think the analogy I used was something like, it may or may not rain. There's a 77% chance of rain, but we could be wrong. We're still going to bring an umbrella to work. So in other words, it's still telling us something. This is not random. There's something going on here, and these factors do have an impact. And that's really the extent of it. So just upfront about it, saying, this is not a great model, but it's okay for what we need it for.
Excellent. And I believe this will be our final question. The data that you used to get this demo, was it cleaned, or do you have to analyze it first and then create your analysis and reports based on that?
And the data for which part?
I think it's referring to the same demo with the 0.777 AUC.
Oh, yes. And so the question is if the data was clean or if we had to do some things. Right. It was some of it was. So we had different kinds of data. We had sensor data on player movement, which was except for the orientation, it was very clean. So it's actually pretty cool. The players, the NFL players, all wear a sensor on their shoulder pads. And during the course of a play, every single game, the sensors report their location 10 times a second. So with those specific locations, you can calculate, your speed, your acceleration, you can track direction of movement, you can do all these different things. And that data is actually nice and clean and accurate. You have to do some things to filter out, before the ball is in play and after the whistle's blown, but otherwise pretty good. Other data needed some work for sure. The weather data and some of those things, just stadium type, a lot of misspellings and just strange entries, but nothing that you wouldn't see otherwise. And so there was a little bit of cleaning that had to be done there. The big thing with this was it was anonymized data. So because it had to do with personal injuries and such, there's some anonymous elements that made it hard to draw things together. So that was the one thing I think that would have helped with the cleaning and with the model effectiveness.
Great. Okay, so I want to thank you, John, for taking the time today and doing a great presentation. I'd like to say thank you to everyone who joined us as well. The presentation slides and the recording will be made available on our Bright Talk channel. And have a great rest of your day.
Thanks, bye.